One of the things that we should not do when preparing for the CCNA exam is make assumptions. Yeah, you will often find students making assumptions. They'll say, oh my gosh, I'm not going to have to perform static routing in the CCNA exam. That's ridiculous. If they're going to have me practice with routing, it would certainly be OSPF. So what does the student do? They don't practice static routing, and then they need to configure it, and they are having trouble with it. So sure enough, Chapter 15 of our text is dedicated to IPv4 and IPv6 static routes, and here we get to experiment with those. Now notice our first task is to create a static route on R1 to reach the 172.16.1 network on R2. And we are going to use the next hop IP address of R2 when we create this static route. Well, wait a minute here. We have R1 and R2 directly connected. So I'm thinking if we go down and take a look at R2, I'm thinking that must have been implemented, that remote network, with a loopback. Let's do a show IP interface brief and see if that's what happened. And look at that. It's exactly what happened. So to compensate for the fact that we only have two routers here directly connected through a switch, we needed loopbacks, sure. And sure enough, if we look at the routing table on R1, so if I do my show IP route, we have no awareness of that remote loopback IP address. Sure, we're not going to know about it. We're only going to know about the 192.168.1 network that connects these two devices. Hey, speaking of, one of the things that we need is we need the R2 gig 0/0 IP address, because that is going to be our next hop when we create the static route. So I might as well go ahead and grab that to the clipboard. So there is going to be our next hop for our static route on R1. Sure, that's going to be a big help. Got that on the clipboard. And so now what I'm going to do is go to R1 and actually create that static route that we are asked to create in step 1. So how do we do this? We're going to go into global configuration mode, and we are going to say IP route. And we want to route to 172.16.1.0, and the mask is going to be 24 bits. And what we're doing here in this portion of the static route is we're just being sure not to have any typos. Yeah, you want to make sure you get the prefix and the mask just perfect. Remember, context-sensitive help is available to you. Yeah, in your exam, it's going to be there. So if you forget what comes next, no problem. Just do your context-sensitive help. And notice what we can do next is we can give the forwarding router's address, that next hop. So I have it copied to the clipboard. I'm going to paste it right in. And do we need to do anything else? No. Notice we could set a administrative distance metric for this route. Yeah, we could set the AD of the route. And you might think to yourself, well, wait a minute, why would we ever want to do that? Well, that would be to create a floating static route. So if we want to take this static route and give it a large AD, maybe like we give it an AD of 112, so that OSPF can tell us how to get to this destination, and only if OSPF fails would this static route be used. So that is a really neat technique with static routes called floating static routes, but notice we don't need to do that in this scenario. So I'm going to just hit enter, and now we need to do some verifications, obviously. The first verification I'm going to do is simply show IP route, and I'm going to make sure that our static route is in the routing table. Yeah. Now, can we test this by pinging the loopback address that is on the R2 device? I think we can. So let's do that verification. Now, I'm about to leave this router, so I'm going to save. As you probably know from watching these videos, I like to save my configuration before I leave any router in my exam. So I'm going to go over to the R2 device, and over on R2, we had already done a show IP interface brief. That's handy. Here is the 32-bit address that is on that loopback. So I'm going to copy it, and then I'm going to go back to R1, and sure enough, we are going to just ping that IP address to see if we have had success with our static route, and look at that. Thanks to our static route, we can now reach that loopback interface. It's always great to just kind of sanity check why that worked. R1 has a static route to that loopback subnet, and what happened was we pinged and we reached that loopback, and the loopback saw the source of the ping, which is that 192.168 that it's connected to, so it was able to return the traffic back. Yeah, this is not a scenario where the traffic can't make it back to the source, because that would, of course, cause the ping to fail. But in our scenario here, we just needed a static route on R1 pointing to that loopback in order for pings to succeed. Gotta love it. All right, now in step 2, we need to create a static route on R1 to reach a IPv6 network that is on R2. And once again, we're going to be using the R2 IPv6 address as the next hop. Wow, so we're doing basically the same thing, but in our IPv6 world. So let me go ahead and go to R2 again. And this time, instead of show IP interface brief, we're going to do a show IPv6 interface brief. One of the great things I'm sure you've noticed about IPv6 is all of the commands that we need in Cisco are basically just substituting the IP keyword for the IPv6 keyword in the command. Yeah, pretty neat. Here is the IPv6 address that is going to be our next hop. Yeah, it's on gig 00. That'll be our next hop. So notice I'm using a very similar approach here. I'm going to copy that to the clipboard. I am now going to go to R1, and we are going to create the static IPv6 route. Once again, we go into global configuration mode, and I'm going to say not IP route, but IPv6 route. And what is the prefix we want to route to? It's 2001, and then 4 ones, and then 4 ones, and then we are going to say :/64 to indicate the subnet we want to route for, and of course the prefix defining that subnet. Now, what is our next hop address? I just need to paste that in there. And context-sensitive help, sure enough, we could make this a floating IPv6 static route if we wanted, but that certainly appears to be enough configuration in this scenario. So I'm going to hit enter. I'm going to end, and I'm going to do a show IPv6 route to verify that we have our static route. I'm going to save. And now I'm going to go over to R2. Notice it's the same exact workflow I did for IPv4. And what I'm going to do is grab an IP address that is on that subnet, on the loopback. I'm going to copy it, and I'm going to go over to R1 as a final verification, and I am going to ping it. So I will come over here and do a ping and paste in that IPv6 address that we can now reach just fine. Notice that there was no packet loss due to address resolution protocol. And that is because IPv6 does not use address resolution protocol. That's right. So goodbye ARP. And sure enough, we don't have any packet loss due to the ARP process. Well, all of our configuration was made on R1, so I don't know why I just closed the window. I want to save one more time there, and I do believe we have succeeded with the Chapter 15 review. Let's check our results, and yes, we have gotten a perfect score in our use of IPv4 and IPv6 static routes. Thanks so much for joining me.